All right, well, thank you to Jonathan. And next up, we have Dr. Rin Zhongli Owen. Come on out.
Cool. Yeah. Thank you, Mark.
Here you go.
Okay, good morning, everyone. So I'm a physicist. I got my PhD in Heidelberg in Germany in 1995. I'm here today to start with. Let me first ask a few questions. Okay, so who are we, and where were we from, and what is the future destiny of all of us as a mankind? Okay, these are the general questions that for thousands of years mankind has wondered about these questions here. So this is why today I come here to talk with you the open science and open infrastructure. I will use CERN, the European Organization for Nuclear Research, as the example and use case to demonstrate to you why open science research is interesting for our society and what we can gain from that and why that is relevant with open infrastructure. I will try to explain to you that open science requires very often the innovative new solutions, industrial solutions, technology solutions, and the open infrastructure developed this community here that provide exactly such a solution for us. You guys are also trying to help us to shape the future evolution of open science in data storage, in computing. There is a general skip of my talk. Now, what you see on the picture is a bird's view picture of the local Geneva area. You see from the northwest to the southeast. You see Mont Blanc at the background. You see the Lake of Geneva. You see the airport of Geneva in front. That is normally 4 kilometers in length. This is to be compared with 27 kilometers circumference called Large Hadron Collider. This is by far the largest and highest energy particle accelerator on the world today. This machine is buried roughly 100 meters underground near the lake and 150 meters underground near the Jura Mountain to the northwest of Geneva in France. Okay. This allows thousands of physicists from all over the world to do fundamental physics research and energy frontier. Okay. Now, CERN stands for European Commission for Nuclear Research. This commission was formed immediately after the Second World War to discuss how to set up a lab like CERN today. So the institute was founded in 1954 outside of Geneva with 12 Western European countries. The motto of this institute was Science for Peace, as you can see on the slides here. So this institute today becomes really international. There are 23 member state countries today. There are roughly 3,000 staff members. And the most important thing is that it gathers more than 12,000 people from all over the world doing fundamental physics research and CERN over there. You see all the member state countries. You see now it's really international because it's still called European Center for Particle Physics Research, but now you see countries like Israel, like Pakistan, like India, they are already member states of CERN. Okay. So the mission of CERN, what we can gain from this is fourfold. Okay, you see the triangle here. One is the fundamental research, one is the technology innovation, and the education and training. And the fourth one is uniting people from different cultures. Okay. As we mentioned, we produce knowledge with fundamental physics research and energy frontier. For example, I give you an example. We have dark matter, we have dark energy in the universe. We also don't understand why the universe is formed with matter. We don't see any primordial antimatter left in the universe. All these cosmological puzzles are now being studied here. And CERN with the Large Hadron Collider over there. Okay. Some research work got Nobel Prize for that. We don't have time to mention that. But the second thing CERN produce is that to produce new technologies. Okay. The famous example was the World Wide Web for information sharing, and now with the massive data from LHC, we get worldwide computing grid, and with the touch screen technology, just to name a few of them. Okay. The third thing is that it serves like a training site for scientists and engineers for tomorrow. So if you check, there are 3,500 PhD students working here, working at CERN today to pursue their PhD thesis over there. Okay. The fourth one is uniting people from different countries. Okay. We can safely ignore this. This is talking about the Big Bang cosmology, since we don't have time. Now, this one is interesting. You see a ruler, cosmological ruler, that shows you the size of the universe from beginning of the Big Bang up to today. So the Mark is sitting in the middle of the ruler. He is a delegate of a human. He sees to the macroscopic direction. He sees the size of the universe. To the microscopic direction, what we can see is 10 to the minus 18 meters in diameter. There is a limit, technology limit we can achieve today. We cannot see smaller than that, okay? Anyway, with the macroscopic side, we have space-borne experiments, surface experiments that studies all these fundamental questions. And CERN people are using this Large Hadron Collider as a super microscope to see smaller distance over there, okay? This is why it's interesting, but we answer similar questions, okay? Now, this one, again, you see the Large Hadron Collider on the background picture here. We have 4 gigantic detectors, okay, ATA, CMS, and ALICE, and LHCb. These are 4 gigantic 3D digital cameras that take photographs when the collision happens in the center of the detectors over there. Why that is interesting with us, for example, these 2 gentlemen got the Nobel Prize when the Higgs boson, the so-called God particle, was discovered over there. Now, that is relevant with us is that we produce massive data. In reality, this data already reduced amount of data that according to what kind of IT resources we can get from you guys, okay? In reality, we get 1 petabyte of data per second from each experiment. We have 4 gigantic detectors over there, okay? I will not read this, but I don't have time, okay? Now, these are the fact sheets of the LHC. As I mentioned, when you construct big and big machines, you push the technology into France, or even beyond the limit. Then you produce new technologies, okay? If anyone is interested, you can read that afterwards, okay? Now, so the international sector talks about something called CERN model. Why they want to talk about CERN model? Because they want to understand how CERN can unify 3,000 people from all over the world to work together for 18 years' time to make a unique detector like LHC detectors over there. You want to learn from CERN experiments to make the better collaboration in the United Nations framework over there, for example. This is something interesting for us because now we talk about open infrastructure from this community here. Okay, as I see that now there are more than 103,000 community members in this collaboration. There is almost a factor of 10 times larger than the high energy physics research community and CERN. So this global collaboration here produce open source tools that shapes the future for the open science research over there. Okay, this is why it's interesting for us. I mean, since we don't have time, I simply want to simplify, summarize that what we can see that next open infrastructure meeting, probably people will talk about the model of OpenStack collaboration projects here. Because this is much larger collaborations. If everyone works coherently, constructively, you get something out. If everyone fight with each other, we don't get anything out of that. Okay. So thank you.
So thank you, Dr. Rin. So I would just like to start by describing a little bit of where we are at CERN with regards to OpenStack. So currently at CERN, where we do the data recording, we have around 300,000 cores running under an OpenStack cloud. The key focus over the past year has been how to provide an easy Kubernetes as a service infrastructure on top of OpenStack. And for that, we've used the Magnum project. And we have now over 500 different Kubernetes clusters running on top of the cloud. On top of that, we've been using the bare metal service, Ironic, to start to register every single server that is in the CERN computer center. Currently, we have around 4,000 machines, and we'll head towards 15,000 as we go forward over the next year. All the code for this is being contributed upstream, including software RAID, cluster healing, and that is then arriving as part of the standard distributions. So there is a technology part, but there's also an organization and process part to deploying a cloud. For those of you that have cats, you know the problem. They come to the door to go out. They stand there, they look up at you, and they expect you to open the door for them. So you open the door, and then you think, right, I'll buy the best technology I can, a cat flap. It's going to have a security check control to make sure it's your cat that comes in and goes out. And what then happens? The cat walks up to the door and then looks up to you affectionately in order to be let out again. And deploying clouds is like that. You need to, on the one hand, support the users that are going very fast. On the other hand, you need to make sure that you don't stretch the organization too much. And the people who are running legacy applications need to also be supported. And the flexibility that OpenStack provides is very useful in that way. Openness is part of CERN's culture. So we've been driving strongly the idea that says research publications should be available free for use over the net. You can understand physics research by looking around and getting access to those publications. At the same time, we want you to be able to be a physicist for a day. So on top of the OpenStack cloud, we run an open data portal that has high-quality data sets. If you're a teacher, you can teach your class how to do high-energy physics. The other thing you can do with this is to reproduce the results from the past experiments. Examples of this is the Higgs Discovery. So with this, we ran on our OpenStack cloud using Magnum the reproduction of the analysis that discovered the Higgs. At the same time, we were then able to take exactly that workload and run it on a public cloud, and in 10 minutes, we discovered the Higgs. So you too can do that discovery. The only slight problem is you'll need 25,000 cores in order to do it. But it's not just a question of building a cloud. That's just the core part. You need to integrate everything around it. And this is where the open ecosystem has been very good over the past few years. We started off, we had to glue a lot of things together. Now that integration is built into open source projects. So one open source project supports integration of another. And with that, you can build and integrate these stacks very, very easily now. So looking forward, we recorded around 100, 150 petabytes last year. We're looking to go to about 60 times that by 2025. But CERN is not on its own there. CERN is facing the same big data problems that other large scientific experiments are facing going forward. So with that, what we do is we form communities. So working with the radio telescope, the square kilometer array, working with neutrino experiments, working with gravity wave experiments, we're addressing the general problem of how do you handle large-scale scientific data. So the key part there is collaboration in the open. So 30 years ago, the first paper on the World Wide Web was published. CERN put that into the public domain, helped form the W3C Foundation to look after that activity. In the same way, CERN's working on areas like OpenStack. We had an OpenStack event at CERN this year with over 200 people coming on site to discuss OpenStack and science. We also had the chance to take Mark to the antimatter factory. But that's the benefit of potentially the next few days, which is you get a chance to interact with the rest of the community and benefit from their knowledge. So enjoy your time here. Thank you very much.
Thank you, Tim and Dr. Rin. I don't know about you all, but I find CERN to be just one of the most amazing and inspiring stories of open source and OpenStack, not just advancing technology, but human understanding. I had a chance to go visit back in May, and the facility is incredible. The smartest physicists in the world are all studying there, and they're using open source for good.